You'll be delighted to know that the rules for multiplying and dividing integers are a good deal simpler than the rules for adding and subtracting. Take a look at this pattern. We're going to kind of illustrate the rules before we actually write them down. Notice I have 5 times 4 here is 20, 5 times 3, 15. And in this pattern, I'm keeping the first factor the same all the way down, 5 for every one of them. And notice the second factor is decreasing by 1 all the way into negative values. And what we want to notice is the pattern for these products. 5 times 4, 20, and then 15, and then 10, and then 5, 0. And if we continue the pattern, we're seeing that the value here is decreasing by 5 all the way down to 0. And if the pattern continues, we would get negative 5 and then negative 10. And certainly this is the case, that 5 times negative 1 is negative 5, 5 times negative 2, negative 10. So when we multiply a positive number times a negative number, it seems that we get a negative result. And this kind of makes sense too if we think about the multiplication in terms of repeated addition, because after all here we could think about having 5 add-ins of negative 2. You see, we're adding negative 2 5 times. So it would be negative 2 plus negative 2 plus negative 2. You see 5 add-ins of negative 2 would give us a total of negative 10. All right, so the general idea is that when we multiply a positive number times a negative one, we get a negative result, a negative product. Now let's take a look at another pattern. If we agree that positive times negative is negative, and we know that with multiplication we have this commutative idea, so here I have a negative number times a positive number giving a negative result. And once again, the pattern is similar to the previous one. I'm keeping the first factor consistent, the same, negative 2, and I'm taking the second factor and reducing by 1 down into the negatives. And we'll see a pattern over here with these products. Negative 2 times 4, negative 8, then negative 2 times 3, negative 6, then negative 4, negative 2, 0. Now, notice the pattern here, negative 8, negative 6, negative 4, negative 2, 0. If we were on a number line, we would be increasing. You see, negative 8 is farther to the left than negative 6. Negative 6 is a little farther to the left than negative 4. So we're marching up the number line. The numbers are getting bigger and bigger. So if we continue the pattern, we go into the positives here. We go to 2 and then 4. And what we're finding is that a negative number times a negative number gives a positive result. And that certainly is the case. Okay, to summarize, it's as simple as this, that when multiplying, and it turns out in dividing as well, with integers, if the signs of the items under the operation are alike, then we get a positive result. We get a positive answer. If the signs are not alike, we get negative answers. You see, so if we're just looking at two factors and we notice that one is positive and one is negative, we're going to get a negative result. If they're both negative, we're going to get a positive result, and that's all there is to it. We don't have to worry about which factor is larger and which one has the negative and the positive sign and that kind of thing like we had to do with adding and subtracting. So this is a good deal easier. Now let's take a few problems here. We're just looking at this. Now the digit part of the multiplication is exactly the same as it has been since arithmetic. 4 times 5 is 20, so that's no big deal. It's the sign pattern here that we really want to look at, and understood plus times minus is negative 20. And here again, we have negative times positive for a negative result, negative 14. And here the signs of both factors are negative, and so we get a positive result, 5 times 8, 40. And I can emphasize the positiveness like this if I want to. Now we'll get to dividing in just a minute, but let's take a few more examples involving multiplication. It turns out that when there are a string of factors to be multiplied, we can actually determine the sign of the answer very quickly. And all we have to do is count the number of negative values that we have in the multiplication process. You see, if it's true that negative times negative is positive, then every time we pair up negative integers, we get a positive result. So if there are, let's see, an even number of negative integers to be multiplied, they'll all pair up with one another and we'll get a positive result. And then again, on the other hand, if they don't all pair up with one another, we get a negative result. The idea is that if we have an even number of negative integers being multiplied, we get a positive result. If we have an odd number of negative factors, we get a negative result. Let's take an example or two. Here we have 3 negative integers, an odd number of negative integers. We're going to get a negative result. And we're going to because in pairing these, like these two can pair up. And generally we would multiply from left to right, and negative times negative would be positive, and 3 times 4, 12. So this is just 12 times the negative 5. And then 12 times negative 5, well, this is positive times negative, a negative result. You see, 12 times 5, 60. So negative 60 for the answer. Now, here's another situation where we have a negative here. These two are both positive. But again, we have an odd number of negative factors, and therefore we're going to get a negative result. And we can see that very clearly if we just multiply 2 at a time. Negative 5 times 8 is negative 40, and then negative 40 times 2 is negative 80. Now the idea here is that when we're multiplying integers, we kind of have a two-step process. We want to identify the sign of the answer, and we want to identify the digits involved in the answer. And we can kind of separate those two notions in our heads. So this idea of counting the number of negative factors becomes a rather important notion. Here we have 4 factors to be multiplied, and they're all negative. And so with 4 negative factors, an even number of negative factors, we're going to get a positive result. So right away we could do this. We could say, okay, the answer is positive, and then figure out what the product of the digits would become. Now to give some validity to this, just understand that when we multiply, if we were multiplying these two together, we'd get a positive result. These two together, a positive result. And then positive times positive would give a positive result. So that's the general idea. Now, if we wish to, we can multiply just in pairs from left to right, and that's perfectly all right. There are an awful lot of ways of arriving at an answer here, but negative 3 times negative 4 would be positive 12. And then 12 times negative 5, plus times minus, minus. 12 times 5, 60. And then negative times negative, positive. 60 times 6 is 360. So a positive product as expected. Now let's go through the various, there are a number of properties here, and they are the properties that are expected at this point, the commutative and associative properties. But I want to emphasize the notion of an involvement with 1 and 0. We would suspect that if we're multiplying an integer times 1, we get the same value that we started with. So negative 5 times 1 is negative 5, and generally any integer times 1 will give us the integer we started with. And in a similar way, we would expect that multiplying by 0 would give us 0. So negative 5 times 0 is 0, and any integer times 0 will give 0 as the result. And here are examples of our commutative and associative properties. They're consistent with the situation that we talked about with whole numbers. 2 times negative 3 would be negative 6, and we get that same result if we multiply negative 3 times 2. So we can multiply factors in either order, the commutative property. And here is an example of the associative property. If we have 3 items to be multiplied, we can actually multiply any 2 of them first, but we can multiply these 2 first if we want to, or we can multiply those 2 first and get the same result. And more generally, A times B times C means that we can multiply A times B first or B times C first, and it doesn't make any difference. Suppose we want to evaluate negative AB when A is negative 2 and B is negative 9. Now, as problems like this become more and more convoluted with these signs involved, it becomes more and more important that we amplify the organizational skills involved. And the organizational skill here is to write the expression we want to evaluate and then replace letters with numbers. Now this minus sign I'll bring down, and replacing A with its value, you see, causes us to have 2 minus signs next to one another. We separate them with the parenthesis, and the B value is negative 9, so once again we introduce another parenthesis. Now there are a couple of ways of handling this situation. One way is like this. We can say, well, this means the opposite of negative 2. So the opposite of negative 2 would be 2. So this is 2 times negative 9, which gives us negative 18. Now another way to think about it is like this. You might think, well, gee, I've been trained to think that parenthesis means multiply. So what am I multiplying by here? What is it? This times that. Well, what is this? It's just a minus sign. Well, we could do this. We could think of it as negative 1. You see, negative understood 1 times negative 2 would be 2. And then 2 times negative 9, negative 18. So either way you look at it is okay. Is 5 a solution to this equation? Well, let's see. If it is, then we'll replace the letter with the value and we should get a true statement. Well, let's see if we do. We have our replacement for z is 5. And on the right, negative 6 times 5, negative 30. Is 30 equal to negative 30? No. So 5 is not a solution to this equation. Let's take a look at some division problems and remember that the rules for dividing integers are the same as the rules for multiplying integers. Here we have negative 24 divided by 4, and we can actually approach this in a couple of ways. And we know that 24 divided by 4 is 6. And we may know right now that because we have a negative integer divided by a positive integer, the result will be negative, and the answer is negative 6. Now, a way to verify it is like this. We could think of it as a long division problem, and this is our divisor, so we would have 4 into negative 24 like this. And remember that this is a request for a number, which is the quotient, which when multiplied times the divisor will give the dividend. That is, what number times 4 is negative 24? That number is negative 6. So once again, we're relating this idea of division back to multiplication in this way, and we're verifying that the result is negative. All right, at any rate, we probably wouldn't write all of that in our day-to-day manipulations. We would just say that this is negative 6. Here we have a negative number divided by another negative number. Negative divided by negative is positive. When the signs are the same, we get a positive result. So our answer is positive. 15 divided by 5 is 3. Now let's talk about 0 again. Recall that 0 divided by negative 5 or 0 divided by some non-zero value is going to always be 0. But on the other hand, when 0 is in a denominator, this is 18 divided by 0. This is not a possibility. This is an undefined value. And it's important to understand why. If you ever get confused about these two and you're not sure which is which, just to set it up as a long division problem, here this is 18 divided by 0, so we would think of it like this. And we would be asking ourselves, is there a number such that we can multiply times 0 to give 18? What times 0 is 18? Well, no integer times 0 is 18. Anything times 0 is going to be 0. So we can't answer this request, and therefore the answer is really undefined. Let's go through a few more. Now, I want you to notice the similarities between these three forms. We have negative 20 divided by 4. Negative divided by positive is negative. 20 divided by 4 is 5. So the result here is negative 5. This too, the result is negative 5. That is, the signs are different, so we get a negative result. 20 divided by 4 is 5. And here we have a sign preceding this fraction. So although fractions imply division problems, fractions are just fractions in a lot of situations as well. So we can think of this as the negative of 20 divided by 4. You see, the negative of whatever this is. And this is 20 divided by 4, or 5. So here we get negative 5. Now, the important point here is that because these all have the same value, they are equal to one another. And I want you to notice that in all of these fractions, we have one single minus sign, one single negative sign. Here it's in the numerator, here the denominator, and here the sign of the fraction. And it turns out that fractions can always be thought of as having three signs involved in them. The sign of the numerator, the sign of the denominator, and the sign of the fraction itself. And if you have one minus sign involved there, just one, then that minus sign can float to whatever position you would like to put it into. And sometimes it's real handy to allow ourselves to float that minus sign from this position to the numerator, for example. We might want to rewrite this in this form for a particular purpose. And if we were giving this as an as an answer in a certain problem, the minus sign usually floats to the position of the sign of the fraction, so it could float to this position. Okay, so alternate forms of signs and fractions. Suppose we want to evaluate a divided by negative b when a is negative 28 and b is negative 4. And we've seen this a number of times before, and the trick is the introduction of signs and the convolution that is caused sometimes by introducing extra signs into a problem like this. Here we would begin with a divided by negative b. Now I'm just writing it the way that it is above, but you know I could write this as a divided by negative b like this, and it would be just fine. But let's stay with this form and see how it turns out. Let's see, a is replaced with negative 28, and let's see, divided by parenthesis minus. Now, and b though itself is negative 4. So this minus sign is this one, you see, and then we introduce b as negative 4. So we have minus negative 4. And once again, we need to separate with some kind of symbol of inclusion. Now, a lot of times when symbols of inclusion are nested like this, rather than write double parenthesis on both sides, a lot of times it's a little easier to see the situation if you use a different kind of symbol of inclusion, like brackets. You see, and now here this is the negative of negative 4, or it's negative 1 times negative 4, or it's the opposite of negative 4. But any way you cook it up, this turns out to be 4. You see, so this is really negative 28 divided by 4. And dividing here, the signs are different, so we get a negative result. 28 divided by 4 is 7, so negative 7 for the result. Is negative 4 a solution of this equation? Well, let's see. We would replace x with the value we have for it here. Negative 20 divided by negative 4. Is that equal to 5? Negative divided by negative is positive. 20 divided by 4 is 5. We have 5 is equal to 5. So yes, indeed, negative 4 is a solution to that equation. What is 0 divided by negative 8? Now, in a situation like this where you have words involved and you have 0 and you're not sure whether the answer is going to be 0 or undefined, you're just not sure, what you can do is set it up as a fraction. You can think of this as 0 divided by negative 8 means 0 over negative 8. Oh, 0 is in the numerator. That's okay. We can evaluate that. It becomes 0. Now, if I swapped positions here, and I had negative 8 here and 0 here, I'd have negative 8 divided by 0. That would put 0 in the denominator and the situation would be undefined. What is the quotient of negative 7 and 1? Quotient of negative 7 and 1. Now, quotient is the answer in a division problem. And when we see the word quotient, we write our fraction implying the division. And the first number after the word quotient is in the numerator of that fraction, and the second number is in the denominator. Now, if we're thinking long division, that would be okay too. Well, the quotient of this number and that one means that's the divisor, and this is the dividend. But generally speaking, in algebra, we would set it up like this, as negative 7 over 1, and this becomes negative 7. You see, an integer divided by 1 gives the integer itself back. Now, if this were negative 1 and this were negative 1, then we have negative divided by negative, which gives us a positive result. Suppose the combined scores of the top 4 golfers in a tournament equaled negative 12. Now, that's 12 strokes below par, as you know from a previous discussion. What was the average score of the 4 golfers? What was the average score? The idea in finding an average is a division. When we find the average of certain numbers, generally if we have a number of numbers to find the average of, we add all of those numbers together. They've already been added here, but generally we add them together and then we divide by the number of numbers we have. Now we're told that the total score is negative 12 for these 4 golfers. And if we want the average score, we simply divide by 4. So it is negative 12 divided by 4, or we could say it's negative 12 divided by 4 like this. Either way, the signs are different. We get a negative result. 12 divided by 4 is 3. So negative 3 is the average score of those 4 golfers.